Before we get to any of this like long distance generational advanced propulsion stuff, we need to actually get into orbit because that's tricky.
It is tricky. Obviously we're getting like better at it now, and there's a kind of a faster advance in our technology to get into orbit. Probably there will be very soon, in these like next few decades, a really rapid, almost perhaps never seen rapid
like
advance,
an explosion of technology,
which will allow us to get in and out of orbit. And obviously now we use conventional rockets, mostly just conventional rockets really, to get into orbit. Which is now becoming more advanced. We get some reusable bad boys seem to be the thing, which is, of course, makes sense. We're going to get some more fancy kind of methane burning rockets, these types of things, in the next few years.
Which are, but they're essentially just like
still conventional
variations
rockets.
of the same chemical conventional.
Yeah, they're just going to get bigger and cheaper,
Mm-hmm.
and more reliable, presumably. So the next stage, I suppose, or there's some arguments that it's not necessarily a good idea as the next stage, but one of the long talked about things is single stage to orbit. So getting into orbit by not jettisoning any hardware, just
a vehicle. It's just a vehicle that flies into orbit and then lands again.
Yeah, a space
totally
plane.
Reusable.
A plane that it tends to be a space plane. It's not always a space plane.
Yeah, there have been some ideas for vertical takeoff, vertical landing, single stage vehicles.
Yeah,
and they always just seem a bit like. Well, we'll talk about it in a second, but they always just seem a bit like almost too good to be true. It's like, just design a magic carpet. Like of course you want a vehicle that can do that, but it's very, very difficult to do.
Yes. Yeah. So one of the ones that's been in the news over the last few years, I mean, it's been in development for quite a while now, maybe.
Yeah.
Well, no, it's from like the 90s or something.
Yeah. The engine tech at least has been.
Yeah. Which is the Skylon, which is a UK-based group from, what's the name of the company?
Reaction Engines. Reaction Engines, yeah.
And they're essentially developing what largely all of it's predicated on a really cool new engine type.
Yeah. And
that cool new engine type is basically, in effect, almost one big innovation, which is the pre-cooler.
Yeah.
So the way it works is that the Skylon is basically like I think it's about 80-meter long kind of space plane design.
It looks pretty cool.
It does look pretty cool.
It's all just conceptual stuff at the moment.
Yeah, but it does look cool.
Yeah, it does look pretty cool.
And they have two of these what are called Sabre engines. Again,
Henge
cool.
name.
Cool name.
They know what they're doing.
And they basically work as a kind of hybrid rocket jet engine.
Yeah. Just air breathing.
It's got an air-breathing stage. So basically, it's got like, on the Blackbird, it's got those sort of shock cones.
Like the ramjet like cones, right?
Yeah, that does have ramjets in it, but it's not a ramjet engine.
Okay.
Well, it's more complicated than that.
Yeah.
It's actually a really kind of like mixed-up engine. It's got all sorts of bits from everything. But basically, the air comes in, slowed down to subsonic speeds. Some of it gets put through this pre-cooler, which is like insanely efficient.
Yeah.
It cools.
Do you know the numbers on it? I mean, I have read them. It goes from like thousands of degrees down to like minus 100 and something in
points,
like a thousandth of a second or something.
Yeah.
It's insane.
It drops the air temperature hugely.
Yeah.
And it weighs very little. That's the key, and that's the key innovation in the engine.
Is it just a really like fine mesh of tubes containing liquid hydrogen?
Liquid hydrogen, which is the thing that the engine burns.
Yeah, so it's just recycling that through the cooling system.
Yeah, it has. So, like with most jet engines, all of the air doesn't go straight down into the engine.
Right.
Some of it goes around the outside, just because they have these that's how they work, these bypass systems.
Yeah.
And because the bypass air would be too slow when it gets to really high speeds, they have like ramjets around the edges of the outside. So the air gets fed back into the thrust at a very high speed, so it goes back out supersonic.
Right.
So it actually has like a circle of ramjets around the edge,
purely just to speed up like the excess air that's flowing around the engine.
That's not
going through the actual compressor.
No, it doesn't go. No, it doesn't. Yeah. This isn't the stuff going through the compressor.
Yeah, that's what I mean.
Stuff going around.
Yeah.
Yeah, so it doesn't slow down the air that's coming out of the back of the actual engine.
Yeah.
And then so basically the like the Blackbird does. Those cones at the front, those like triangles, shut as it gets faster and faster and faster, letting less and less air in, until it gets to a point where it's I think it's about Mach 5.5.
Mm-hmm.
Nice. And at that point, it's going too fast. Now you can't get rid of the heat fast enough.
Yeah.
So you shut the front off, and then you just stick in a load of liquid oxygen as the oxygen instead of the air.
Yeah, and then just fire it like a rocket engine.
And then it just burns like a rocket engine, and you get into orbit that way.
I mean, that is all fucking cool.
Yeah, it is really cool.
Yeah.
And I think...
And then it just lands like a plane.
Yeah, it takes off like a plane, it lands like a plane. I think it has to have a pretty massive runway, though.
That's the thing with... So it's not the air-breathing stage of it is not a full ramjet, is it?
It's got a ramjet part. It's not a ramjet.
It's not a ramjet, because ramjets, you need to be going like Mach 3 or something for them to actually start working.
Ramjets actually have the weight of and power of a ramjet. Weight to power ratio or whatever is nowhere near as good as the Sabre engine.
Okay.
I mean, same with scramjets.
Yeah. So this is being developed. I mean, they've got to the point where they've tested the cooling system on a prototype engine.
The cooling system's got the big tick from the European Space Agency as being like, okay, on
works.
paper this works.
Yeah. And they piled a load of money into reaction engines and stuff.
Yeah. I think BAE have bought 20% of reaction engines.
Oh shit.
For a certain amount of money, I forget which. And I mean that money is going to be used to they basically are backing that as a technology in the future.
Okay.
I think it's BAE or maybe Boeing, but I think it's BAE.
But the actual vehicle itself, the Skylon plane, is a long way off, actually being built and tested, etc.
Yeah, the engine is going to be tested. They're hoping to have a full working prototype engine, a fully almost ready to go engine by 2019. So that's a while away.
That's a while away.
And they think it might be flying by about 2025.
Okay. I mean, it'll come around quickly, I guess, but there's going to be a lot of other changes happening in the meantime with other industries and other technologies.
Yeah.
But I mean, if it works, it's going to be fucking cool.
It'll be really cool. So some of the stuff it brings that you can't. I mean, there's some debate as to whether it's actually going to be
better than reliably reusable rockets.
Yeah.
Yeah.
It can do some. It's got a very fast turnaround time.
Yeah.
So you can turn it around potentially in sort of 2 or 3 days. But we don't know how quickly you could return around a reusable rocket.
No idea.
I imagine not that quickly.
Yeah, you would intuitively you'd imagine it would take longer, but maybe that's just because we're used to thinking about rockets as these really we think about rocket flight as being something that's really damaging to the vehicle and stuff, and maybe we'll find from these SpaceX landings and stuff that it's not too bad. We just don't know at this point.
No, and also same with
territory.
reuse of the space plane. I think it is thought that you would be able to reuse the space plane more times than you would a rocket you land vertically.
Yeah.
I think partly just because of the energy expenditure and stuff. The rocket just goes through more stress. I think, or the rocket engines do. There's just more energy expended early on.
Yeah. Okay.
Obviously, it has a rocket burning stage later, but it's when it's already higher in the
atmosphere.
Yeah.
I think the aerodynamic pressure experienced by a space plane lower in the atmosphere is probably less than it would be for a rocket.
Possibly.
I don't know if that's actually true.
I'm not sure. But there is a suspicion that you would be able to potentially use these things, reuse them more times, say 200 times instead of maybe 10, 20 for a rocket. Yeah. Again, we don't know how far advanced these vertically landing.
I wonder how scalable the technology is though, because at the moment the Skylon design is obviously a certain size.
Yeah.
And that's great for getting small payloads into low Earth orbit. But could you make a giant space plane for taking absolutely massive payloads?
Well, it already takes in quite a lot, so it's comparable. It's from 12 to 15 tons you can get into low Earth orbit, which is about Falcon 9. Falcon 9 1.1's about 13 or something. 13 tons. So it's in that range.
That's pretty good. Yeah, that's pretty decent.
And because of some other things, you can also do. That's just the space plane. I think then it can have extra stages that come up and do various things. Yeah. But you could potentially take in, according to Reaction Engine's website, up to 30 astronauts.
Shit.
And I'm not quite sure why that you can't. I guess, can you not do that in a rocket because there's not enough? Could you not design a capsule that could take 30 on a Falcon 9? Yeah,
surely if it's just the same mass.
Yeah.
The same range of mass as a Falcon 9, then what's limiting you? Just
I
space,
don't know.
I
it
guess.
Might be. Yeah, space exactly. But
yeah, because the rocket you have to take more fuel because you have to take all of your. It's not air breathing at all, so you have to take all of your oxygen with you. So this vehicle has more space.
The rocket you have to take more all your oxygen.
That's what I'm saying. Yeah.
Oh,
rocket.
Sorry,
you take all the oxygen. So a lot of the vehicle is full of just tanks, like fuel tanks, oxygen tanks, all that shit. Whereas with the Skylon, we have greater space in the vehicle for payload.
Yeah, maybe that's true. Yeah, because obviously you're burning hydrogen and then only oxygen towards the top.
Although a significant portion of it is still just given over to tanks.
Yeah, it is just like
it's just a giant
two massive tanks.
Yeah.
If you look at the interior design, it's two massive.
Like a little bit
tanks,
in the middle for
a little bit of oxidizer tank, like not so big, and the middle kind of cargo bay is tiny. Really.
Yeah, it is tiny.
So we'll see about these space planes. The other argument is so we talked about it can do similar things perhaps to these landable rockets.
Yeah.
There's some debate as to whether it will be cheaper. So that's going to be one of the clinches, isn't it?
Yeah, I mean that's going to be it basically.
Yeah.
What else does it come down to? At the end of the day, if you can launch things more cheaper on rockets, well, reliability is the other thing.
Yes.
But that gets kind of folded into cost in a way.
Yeah.
Like you potentially be paying more for something that's more reliable.
Yeah. I was looking over some of the numbers that people have suggested for the Skylon, how much it would cost to get into orbit.
Right.
And none of them are consistent. They seem to be all over the place, saying how many pounds of whatever.
Right. Yeah.
But for example, I think basically when you do some of the maths, it ends up being in some configurations potentially cheaper than a landable, reusable rocket, but potentially more expensive as well. So somewhere in the ballpark, that they're probably not going to be that dissimilar in price per initially anyway.
Yeah.
The thing that really might get the spaceplane though is the long-term reusability of them. And the fact that there's an earlier technology. The rockets are much older, of course, and we understand them better. So the long-term reusability of these planes is going to be like a clincher. So I suppose it's just...
And now time will tell, basically, what comes out of that.
Yeah.
I do wonder, space planes like the shuttle was a space plane, essentially.
Yeah.
I mean, it's very different. It didn't horizontally take off like a plane or anything like that. But essentially, it's a space plane.
Yeah.
And something that we know is a problem with that is the heat shield is just weaker than like the kind of really simple circular heat shields you get on capsules. So maybe you find that kind of thing is going to the reliability of one of them, the heat shield on the Skylon, for example, has got all these kind of complex like corners and angles and stuff to keep heat out of.
I was about to say, I actually don't know much about how that keeps heat out, because it doesn't...
Well, it must just have a heat shield comparable to the shuttle or something.
But it's like designs. It doesn't have like an obvious kind of ceramic tile layer.
It's all black. It's like
it does
just
sort of... But isn't... I would have thought that would be on there. I really don't know much about it. How it deals with re-entry.
I'd be quite interested in hearing a bit more about that, actually. But that is something that space planes... The simplicity of like a capsule is that you just have this like really simple single piece heat shield, which is much more reliable than having these overlapping tiles or whatever they have on space planes. So that's something that you know.
I have a feeling it doesn't. I don't know. I'm not sure off the top of my head exactly what it has.
Maybe maybe materials technology is advanced enough that you can just clad the whole thing in some kind of crazy.
I don't think it has though.
I'm just making shit off the top of my head. I don't know. I need to read into this because it's cool. It's an interesting. It will impact the reliability and stuff
hugely.
Massively, and how reusable they are, and you know whether they need much the refurbishment and how that compares to rockets and things like that.
Although the problem with this, I suppose the problem with the space shuttle's heat shield was obviously that it was much bigger, but the problem with it, the reason the heat shield failed was because some bit of the rocket initially like smashed a tile, right?
Yeah, it smashed a tile. But I think the argument was that if you'd had that wouldn't have been possible, even if you'd had like debris impact like a heat shield of a capsule, because they have all these overlapping.
Place, though,
yeah, you have all these overlapping tiles, and like one can get knocked off, and that can compromise the whole vehicle.
Yes.
But maybe I don't know. But that is definitely an aspect.
The heat shield is like protected when a rocket goes. It's normally on the top, isn't it? And it's normally sat underneath where it like attaches.
Yeah,
it's normally like within the second stage or whatever.
Yeah, so it's not as vulnerable.
It's not actually exposed. I guess the Skylon doesn't have stages, so it doesn't have that problem as such.
No. That's true. Yeah.
But it's still one of those things. The Skylon's going to be totally. Obviously, it might be astronaut rated, but it's going to be totally automated. So it's not going to have like a...
Yeah, it's going to be autonomous.
So, I mean, that's not so much... When you've not got to take people in on a consistent basis, one blows up, it's like, it's annoying.
Yeah.
It's a waste of money. But it could, it's not the end of the world. But if they want to make it human rated, then obviously that's a whole pain in the arse. Because they were talking, weren't they, for a while about going outside the space shuttle. There was kind of this discussion as to whether, before it blew up, burnt up,
whether they had to go out and check
whether
everything.
they should go out and they'd make the decision not to check it. And then there was that there was talk about
Sketchy.
whether obviously ended in disaster.
Yeah.
But it was whether they could have actually saved them anyway. Another shuttle was already lined up. And was X number of months away from being ready, so they potentially could have rushed it through. And thinking, based on the supplies they could have had, they might have actually been able to do a rescue mission, which would have been pretty cool.
It would have been cool, yeah. It would have been.
It's like Apollo
super
13.
dramatic, super tense, kind of.
Yeah.
Just playing out on the news and stuff would have been insane. But that could have potentially ended in a double disaster if you rush the second shuttle through its prep.
But if
and
you
then
can't,
that one fucking blows up as well. Oops.
But one thing is, you can't do necessarily. It might be hard to do spacewalks on a totally autonomous vehicle. Yeah. If you've got a human crew that are in there, they're just sat there they can't. They're probably not going to be able to get in and out of it in the same way that the shuttle was designed for kind of spacewalks.
Yeah. Although it will be under ground control to a certain extent. I mean, there's not going to be its operations all going to be automatic or whatever.
True. But maybe you could do a spacewalk. It's mass. How big is it compared to the shuttle though?
I'm not sure.
How long's the shuttle?
I don't know.
I think it's quite a lot longer, isn't it?
How long is the Skylon? Do you know?
82 meters or something.
That's big.
It's
really
longer
big.
than a jumbo jet.
Yeah.
Of course. Well, you sit the weren't they transporting the shuttle on the back of a giant?
Yeah.
Was it a jumbo? The Americans doing it on a jumbo.
Yeah. 747, I think.
There was that massive Russian jet that was taking the Russian.
Yeah, that thing is giant. That is unbelievable. I can't believe that thing flies.
Yeah.
Like a skyscraper in the air.
But I have a feeling Skylon's quite a lot bigger than a shuttle, the actual vehicle.
Yeah, it'd be cool to see one. Imagine seeing one sat on the runway, at a spaceport, where there's a fleet of these things.
They'll have to make them take off on the runways in very specific places, because they'll be going hypersonics. They'll be bloody noisy as they're going up.
Oh, that would be awesome to see one of those things take off.
You have to have them taking over oceans, because you're not allowed to actually go supersonic speeds as commercial planes. Concorde wasn't allowed to do that over land.
Yeah, they're talking about building spaceports and stuff in Europe and the UK, actually. I don't know why. Surely you want to build it somewhere where you have reliable weather.
Yeah.
Not like an island in the North Atlantic where the weather's fucking crazy all the time.
I don't know, maybe it's because the Atlantic's there and you can just sort of...
Yeah, but that's it. That's what I was maybe just about to say, is that,
that's why
you take it off over an ocean, so you stick it on an island next to the Atlantic. It kind of makes sense.
Yeah. So yeah, Skylon looks cool.
Skylon looks cool.
It's cool that it's a small company as well.
Yeah, it's nice to see that.
You don't see that very often.
Seeing it more and more now with space technology. So
that's true.
They're another up and coming company to kind of keep your eye on. Not really doing anything in terms of launch now, obviously, but they will be, hopefully. Yeah. It's also nice that they're British, just because it's a country that's just traditionally not been that involved in space activities so much.
Not in the same way.
There's a lot of British satellite companies building satellites, but certainly not in access to space. So it's all good.
No, exactly. Yeah, just getting everyone involved.
Yeah,
is a good thing.
So there's a few other space plane designs kicking about. Some of them government. There's an Indian one called the Avatar. Yeah,
right, okay. Why have they made that an acronym?
I don't know. It makes no sense.
Just call it Avatar and forget about the stupid acronym. Yeah. So Avatar, I don't even know what it stands for, but it's ludicrous.
It doesn't stand for... The letters involved in the word Avatar are just buried in the middle of other words. It makes absolutely no sense.
Just call it
the Avatar. Yeah. It's a badass name. And
the Falcon 9's just Falcon's not an acronym of something.
It doesn't stand for anything. It's just I don't understand.
I don't think.
There are some stupid acronyms in science. No, Falcon 9's named after the Millennium Falcon. According to
and the 9 is the 9 engines, right?
Yeah. The Octaweb.
Yeah.
The Avatar is just is a single-stage orbit spaceplane in design, at least.
Yeah, I think some parts of it resemble. It does things like it liquefies the air. I think
liquefying air,
which apparently has not as good efficiency as the Sabre engines in the Skylon.
Yeah, that's right.
And the thing that predated the Skylon, the thing that the guys at Reaction Engines were working on prior to working on Skylon was called the Hotel or something like that, and that had a similar liquefying air engine.
So that's I guess that's a way of possibly getting around that problem of superheated air. So before you have this technology of the cooling system,
it's to do with like how you compress the air, how heavily you compress the air and stuff. But yeah, I guess that's just that's another design. We'll see how that goes.
See how it goes.
There's not as much information, I don't think, about Avatar as there is out for Skylon.
No.
It doesn't seem to have garnered as much interest.
No, but I don't know. We'll see.
Yeah.
It's possible that you'll get like a prototype of that before you get like a Skylon prototype.
Yeah.
But I don't think the capabilities are anywhere near as big. It's got something like 1,000 kilos payload capacity.
Is that right?
So it's going to be small
smaller,
deal. But
Just to be cool.
It's still cool technology development and everything.
Yeah,
so.
could be cheap for putting small satellites in. You'd be suspicious though if they're putting in that small amount in orbit, that it's going to be cheaper than reusable rockets.
Yeah.
Probably. I mean, who knows? The economics of these things are so like murky.
So murky and so just unknown.
Yeah.
Until start using space planes and work out like how reliable and how reusable they are, and
same with the rockets.
We just won't know.
So the other kind of weird design. There's like we talked about the space shuttle. We talked about other designs for single stage to orbit, space planes. But there's a weird kind of outliery one, which is the VentureStar, which is now not in development anymore.
That's a Boeing. It was contracted to Boeing from the American government, right? And it went through all these development stages. Yeah. It's like the ugliest looking thing.
It's kind of odd looking.
It's weird. It's just really like a massive triangle.
Triangle kind of.
I don't really get it. It doesn't look very aerodynamic for a start.
It's a really bizarre looking like vehicle.
Yeah.
It kind of just like a triangle that sort of takes off vertically. It doesn't have boosters or anything. A single stage, as we said. And it
lands like a plane, so it's a space plane.
Lands like a plane, so it takes off
kind
vertically,
of a space plane,
but lands horizontally.
Yeah, I mean the space shuttle was technically classed as a space plane as well, so I think you could probably lump this in that category, kind of.
Yes. No. Yeah. Sure. I know we're talking about single stage to orbit space planes.
Yeah.
But it is a space. It's as close. Because there's another one that's going to be the shuttle as a space plane. There's another like redesigned small shuttle thing, isn't there? By like Sierra.
Yes, that's right.
Or whatever.
What's the name of it?
I can't remember. Oh, the Dream Chaser.
Something like that, yeah.
And that thing it counts as a space plane. It takes off, but it goes off on the top of a rocket and basically re-enters the atmosphere in a similar way to almost like a capsule. It's basically a small shuttle, and that's a space plane. But yeah, the VentureStar, the one thing I would recommend looking up on the VentureStar is the photo of the potential engines.
It's fucking awesome.
The aerospike engines.
Yeah, they're amazing.
It looks so unbelievably cool.
Yeah.
It's like kind of like a sort of triangle shape.
Yeah, like a wedge.
Yeah, like a wedge shape.
That's like long, so it's not like a circular cone like you get.
No.
Or like a bell or like a circular cone. No. It's a wedge shape that's like long, and then the thrust.
There seems to be lots of engines. Or I don't quite know how it works, but there seems to be a lot of engines along it.
Yeah, they sort of feed
like have a waterfall of flame down each side of the wedge.
That's a good word, the waterfall of flame.
And it looks so cool.
Yeah, it works in a similar way to like a bell engine, which uses like the outside of the bell to focus the thrust.
Yeah,
it's actually just using like the air pressure on either side of that wedge to focus the thrust into like the point underneath the wedge.
Doesn't that mean that it's really like it's more efficient than normal?
Somehow means it's more efficient. Yeah,
I think it's to do with
loads of altitudes. Yeah, lots of altitudes. Yeah,
I think it's to do with the fact that the bell engines, like you get like the compression of the exhaust from the outside air pressure changes, and you can only make it like perfectly efficient at one height, whereas these aerospike engines are they'll adapt to more
the ambient pressure basically.
Yeah. So I think it's like
so they'll be working at maximum
20 or 30% more efficient potentially than a rocket
which
engine.
is what you need probably for a single stage to orbit.
Yeah,
but the pictures of it look fucking awesome.
Yeah,
like it's so cool. It's a really cool thing.
It's really cool.
Cool to have that just incorporated into more
designs.
But
they ran out of. They basically were doing that work, weren't they, for a while? They did on VentureStar. Like prototypes for it.
If you look at the list of stuff that had to be folded into that VentureStar design, it was. This is what I was saying earlier on about Magic Carpet, because it was literally like, I know, guys. Why don't we just design a rocket that can fly as a single stage into orbit and land like a plane and do all this other stuff? And it's like well, obviously we would have done that if we could have. It's like,
oh really?
Yeah, it just seemed too good to be true. Like reading the list of stuff,
Yes, okay.
It's like Yeah. So, but they had to have all these advancements in materials technology for keep getting the mass right down, and obviously the aerospike engines are a big part of like the thrust, maximizing thrust, and all this kind of stuff. So it had to have all these technologies sort of developed before it could even be a prototype could even be built.
Yeah.
And it just sort of fell apart during all of that.
They had a failure with the hydrogen tank.
Yeah, exactly. Yeah.
Was it hydrogen? Yeah, liquid hydrogen.
Yeah, liquid hydrogen tank.
Yeah.
They had to make it out of some material, and there was like some problem with like the choice of material, and someone like they went down one road and they should have gone down the other road, and it was too late, and it all got kind of it's all buried in like piles of bureaucracy.
They couldn't stop it leaking properly. It had to be a certain weight, didn't it?
Yeah.
But I think a lot of the technologies for VentureStar are like have been developed for other reasons today, and actually it's not. If it was people tried to make it now, it would be a much kind of more fruitful endeavor potentially. Yeah,
which begs the question: is like, why aren't people working on something like this?
Yeah, someone like SpaceX.
Someone like SpaceX. You think that if this was like a really viable, like even though you need to make all these technological developments in order to build it, if it was a viable thing to build a single stage orbit vehicle and it's doable, then why isn't it being done? And maybe that the answer to that is that it's not actually any better than reusable rockets.
Yeah, maybe.
I mean, that's probably Elon's answer to it. I mean, he's obviously will have considered it.
Yeah.
Like him and SpaceX.
Because obviously, like SpaceX could be also. I mean, SpaceX is a rocket company, but would they ever think about developing an air breathing? I mean, it's a totally different like industry. But I know that I've heard in an interview with Elon that he said that when he basically like did the maths or something, looked at it, thought that actually you would always end up being like a cheaper vertically landing rocket. It would always end up being cheaper doing that than having an air breathing stage, and actually it's just better to use rockets the whole way up.
Yeah, but the VentureStar wasn't air breathing.
No, I know it wasn't.
Yeah. So that's what I mean. Like,
so that's why they're not doing space planes, or at least that's why he said that they're not. And obviously it's a different industry, and they need very different expertise. And also the technology is much further off, whereas SpaceX is on a shorter timeline to get to Mars, so it needs rockets. But in terms of the VentureStar, you would have thought they'd investigate something like that if they thought it represented a better way of doing it.
Yeah, but maybe the problem comes from...
But maybe, I mean, you can't, like... Everyone can't come up with every idea all the time. You know, they've got a certain set of experts at SpaceX to do a certain set of things. Yeah. But
it does seem... It just seems like landing multiple stages of a rocket vertically on different parts of the Earth just seems like more of a technological challenge than landing, if you can develop all the right materials and technology for it, than just like taking off a rocket and landing it. Like it's just a total single stage. And maybe the reason is
it's payload.
Yeah, well, maybe the reason is that it's just like economically makes less sense, because you have to actually have to take all of your mass up with you to orbit with a single stage to orbit vehicle. So you have to take enough fuel to take all of that mass with you, whereas with a multi-stage vehicle, you just drop off stages.
Yeah. Because you take all your oxygen and all your mass.
Yeah, and if you're reusing those stages that you leave behind, then it doesn't really matter the fact that it's multiple stages, because you reuse them anyway.
Yeah. You might find something like VentureStar as well, like its maximum capability of stuff to put into orbit is not as high as going down like a whole rocket family that goes all the way, up to the BFR or whatever.
Yeah.
Although that's a different rocket family, of course, to the Falcon. So up to the Falcon Heavy, say. I don't know what its maximum. They thought what its maximum kind of low Earth orbit payloads were, but I wouldn't. It's not going to be like whatever the Falcon Heavy. It's like 53 tons or something like that. It's not going to be like that. I don't think. It was about the same size as a shuttle, similar in terms of like. I remember seeing a picture of it next to the
VentureStar.
Yeah.
Yeah. Well, it's a lot like.
Yeah, it's a very different shape.
It's a lot wider. But I don't know if, in terms of its payload capacity, but you'd imagine that a lot of that space would be fuel tanks.
Yeah.
Just because that's how the way rockets work.
Yeah.
And the thing with reusable multi-stage rockets is that you can drop a load of that halfway up. You don't need to take it all with you.
Yeah. Yeah, no, it's an interesting idea.
But then again, well, I was going to say, then again, if you have all the fuel tanks with you, once you're in orbit, you can refuel and then do other stuff with it, possibly.
That's true. You can still do that with conventional rockets. Once you just have to. You don't have the first stage up there, but you have potentially a second stage that you could refuel.
Yeah.
Yeah. Maybe that's one reason though, is that you could refuel it.
You could refuel it, and then you could do like real deep space, like high velocity missions to go to the outer planets or something.
Yeah, because obviously you can do that by just chucking up loads of conventional rockets.
Yeah, and building something.
Preferably, surely you'd want to do that with as least vehicles as possible within a price point.
Yeah.
Obviously, there's like a price benefit kind of curve there that you fall on at some point, and at some point it makes more sense to build a bigger rocket or use a whatever plane.
Yeah.
Not use thousands of very tiny rockets or whatever.
And maybe the Mars colonial transporter thing, once we find out what that is, the SpaceX thing, is going to be, obviously it's going to be probably a multi-stage rocket that takes it up or whatever. But the actual thing up in orbit that again goes to Mars probably need to be refueled on orbit and then fire off.
Yeah.
A bit like what I was just describing from the VentureStar.
Yeah.
But yeah. Anyway.
Yeah.
So.
What? So if you've got an option then.
Yeah.
Between a normal rocket.
Yeah.
And a space plane.
Right.
So you've got one flight. Okay.
Okay.
You're going to the ISS.
This is my only flight into space I'm ever going to have.
Yeah.
Right.
You're pretty stoked about going to the ISS.
Yeah. Okay.
And you've got a choice between going up in a kind of Dragon 2 type capsule.
Yeah. On a rocket.
Or on a Falcon 9 or whatever.
Yeah.
Or you go up on a Skylon. Which one do you pick? Which is cooler?
Those are kind of two different questions though.
Where you got to answer both of them.
Yeah. All right, that's fine. So the first one. Is a space plane less scary? I think it might be. Because it's not going to be like sat on the pad like fucking venting gas and
all the bits like
humming and vibrating and like just sort of looking a bit terrifying. A space plane's just going to be kind of chilling on a runway like a plane would be.
Yeah, get your headphones on, watch the movies.
So, get your little bag of peanuts or whatever.
The hostess comes around.
Whereas a rocket, but there's something pretty awesome about getting strapped into a rocket.
That's the thing.
Something something, I don't know.
Yeah, there's something more kind of adventurous about being on a rocket.
Getting into a space plane is almost like, it's obviously not like getting into a normal plane because you're going into space and you'll be in like a spacesuit and it's all going to be like a spacecraft inside.
You would be in a spacesuit.
Yeah, probably. But my point is that there will be something about it that feels much more sort of familiar, like you're getting into just a normal aircraft, whereas getting into a rocket is like a new experience, like something totally outside of anything you've done before.
And because there's no windows on the Skylon.
Yeah.
Isn't it? You're not going to be able to see anything.
Yeah, well, that almost just hands down wins the argument then, doesn't it? Because if you want to be able to see what's going on, although actually even in a rocket you probably won't get to see much out of those tiny windows unless you're sat right next to one.
Yeah, that's true. I don't know how much they see in things like Soyuz or whatever.
No.
I mean, it looks like they're pretty kind of like strapped back.
Yeah, although you do see
in the Dragon capsules, it's different potentially.
Yeah, probably bigger windows and stuff. But I think if unless you're lucky enough to be the guy who's like sat right next to the window, which would be wicked.
When you get to the ISS, you're going to be able to look down through the different windows on there. So
maybe that doesn't matter too much. Maybe that doesn't matter too much. No. I wonder what that would feel like, the differences between the two, like whether you get more G or something on the space plane.
Well, maybe.
I don't know. You'd imagine that the immediate acceleration of the rocket would be more.
Yeah.
Would you?
But a part of me thinks like there's something about because it's sort of pressed against it. That sort of like stomach drop feeling you get, like when it whooshes up.
Yeah, and then it kicks when the rocket engines kick in,
and it goes really up into like
fucking firing you into orbit.
That might feel kind of more extreme than just like a rocket's just almost like pressing you in one direction for the whole thing.
Yeah.
Ish.
I know what you mean. I mean, we're not talking from experience, but I know what you mean. Like like I reckon that actually a ride in a space plane would almost be more fun, just because you get the different stages of acceleration, the different stages of like ascent and everything. Because presumably your ascent starts off and like shallower and then gets steeper and steeper as you climb, possibly. And like the different stages of engines, they cycle through from the air breathing to the rocket engine stage. You just get that kick of acceleration.
And I wonder if you wouldn't because I think actually a lot of the astronauts said that the Soyuz is quite smooth now, but sometimes like rockets give a really bad like vibration.
Yeah.
And that could kind of be a bit annoying.
Maybe, but I agree. It's kind of part of the experience of it though, just like the sort of terrifying like. Just assault on your senses that a rocket launch would be.
Yeah, true. I suppose things like the Saturn V launches, I think, were really like vibration heavy.
They looked bad. I mean, based
I think I've heard that before though. Yeah.
Yeah. I think you're right. The story is
So yeah.
But okay, but it's actually obviously not
so
the rocket
which would
breathing.
you pick then? Which are you picking?
Which am I picking to ride into space? To ride into space, I reckon a space plane.
Okay.
For one single... Oh, shit. I don't know. Because the other question, which is a valid question that you raised, is which is cooler, right? And that actually also matters for which one I'd rather go on. So which is just generally cooler, like a space plane? And this is a totally legit question, by the way.
Yeah.
Just pointing it out.
Yeah.
Which is
asked
more...
by many scientists and engineers over the world.
Yeah. Which is more badass, a rocket or a space plane? Hard question.
Well, a conventionally landing. I don't know. Which is cooler? Which is actually cooler? I mean, rockets are kind of. There's something cool about them being old school.
Yeah.
But there's also something not cool about them being old school.
There's something. I know.
There's something way more futuristic about a space plane.
Yes, there is. It feels like it's pushing things forward, even though it might not actually be as viable long term as rockets, so we don't know, as we've just been talking about. But there is something a bit more futuristic about space plane. I agree.
Yeah.
But there's just something about like a rocket, like a space plane. Watching it take off and something. I mean, it would look fucking cool. I can't argue that it's not cool because it's clearly cool. But there's something about just watching it take off would be almost just like watching just a really super cool plane take off, like a Blackbird or something.
Yeah, but how cool is that?
It's fucking cool. But it's not like a rocket launch. Like that thing is going into space, and that's what it's made for, that's what it looks like it's doing. You know, like just the energy and just the spectacle of a.
But the space thing's more like a sort of sci-fi film.
I know what you're saying, and I agree. But to me,
a rocket's cooler.
Yeah. But then maybe a rocket's sort of a bit more stuck in the past, and what I should be thinking about is all these futuristic like.
That's just.
I don't know.
All the different things that go into defining something as cool.
Yeah, so that would feed back into my reasons for choosing one over the other for my single flight into space. Ultimately, its safety would be the overriding thing.
I kind of think that, like we said earlier, it wouldn't be that different to get. For example, I mean, in the future, right? I mean, this is a bit of a tangent, but they're developing the Skylon engine, the Sabre engine.
Yeah.
Another version of it would be the Scimitar engine.
Yeah. Oh yeah.
And that's like for this other, I think it's the A2 or something. It's like a hypersonic,
like a commercial passenger jet.
Yeah, and so even if the economics don't work out for the Skylon for going to low Earth orbit, potentially it's still going to have huge uses for using for commercial planes. Yeah, because like, somebody sort out a supersonic plane. Yeah. It's been so rubbish that Concorde disappeared. I know Concorde was kind of, maybe it should have disappeared, but it was tragic.
Yeah, but there's nothing to carry the beacon forward. No. We're just using the same. I mean, just updated versions of the same air travel that we've been using for like half a century.
Yeah, it's not been faster for a very long time. No. So I mean,
we're way overdue. Like a badass, super fast vehicle to hop around from continent to continent. And it's suborbital, isn't it? Like the design for that thing is suborbital, so you'd be going really high.
I think so, but
so you'd be able to see the Earth as.
But it doesn't know windows. But it will have.
Sort me out.
But it will have like LCD panels. But they said potentially, and like instead of windows, they just have LCD panels. That are relay.
Well, that's sort of okay. But I'd rather it as a window so I can actually see with my eyes what was of the Earth.
Yeah, exactly.
The Earth as a planet underneath me.
Oh, that would be.
Can you imagine?
Just as like you're hopping over to New York, but you get to go in like a.
I wonder what the altitude actually is. I wonder what you would actually see, because it might not be.
It would probably. I think it would be pretty.
I mean, it's pretty high, but it's probably not as high as like the Kármán line, like Blue Origin rocket flights.
No, probably, but I wouldn't be surprised if you would be able to see the curvature of the Earth.
Yeah, I'm sure you will.
You can see
and
that
like
in
the darkness of the sky
plane.
above you, that's space up there.
Yeah. Yeah, when it's going like hypersonic speeds, like Mach 4 or something, it would be really high up.
Yeah. So hopefully in our lifetime we'll be having aircraft flights like that.
Yeah, but I that's a tangent, but it's related because I feel like that flight would feel how much different would that feel to a flight to the ISS on a space plane compared to a hypersonic plane, just the A2 or whatever.
Well, you get up to the altitude of that, and then the rocket engines would kick in.
And then they kick in. That's the thing. Anyway, which is cooler?
Yeah.
I could be convinced it's rockets, but I think it might be space planes for me.
All right. I'm gonna go with rockets. I think rockets are cooler.
Okay.
That's my opinion, which is the word of truth.
That's the end of it. Rockets are cooler.
Done.
Right.
Anyway,
on that note, let's move on.